Right. The last topic of dealing with simple VSEPR compounds is like using training wheels on bicycles. Today we're taking the training wheels off and we're going to get into the more complex multi-central atom compounds. Now, a central atom, to refresh your memory, simply means that there is going to be no hydrogens in the middle, that the central atom is defined as any atom that is bonded to more than one compound, or more than one element. Now, in the past, it's always been the first letter written, and then, unless it's hydrogen, and then it's the next one. In this case, there's going to be more than one central atom. Yes, the first one mentioned will be one of them, maybe two of them, depending on what we have, but you're going to have possibly two different atoms, like a carbon and an oxygen, or nitrogen and oxygen, or something like that, that can be central atoms. Now, technically the compounds that you're about to look at are what we call oxyacids. An oxyacid simply means that, and I think we've talked about this a little bit, but oxyacid means it's an acid that has oxygen. If it's an acid, it's going to have hydrogen. And in oxyacids, all the hydrogens are going to bond to the oxygens, and not to the main central atom. So this is where the change occurs. These are all oxyacids. They're all going to begin with hydrogen, and they're going to have oxygen in them. And what you're going to see is that the central atom is going to be the second element mentioned. All the oxygens are going to bond to them. No oxygens bond to each other. All the oxygens bond to that central atom. And then some, if not all, the hydrogens are going to bond to each one individually a single oxygen. Okay, I said a lot there. It's all about watching it and understanding, so that's what we're going to do. In this video, I'm going to show you 3 different compounds, one of which is going to be regular bonding. The other 2 is going to use that special single bond bonding taking place. So be prepared for that. Here we are. The first one is what we call carbonic acid, H2CO3. This is the stuff that gives soda pop its fizz. Now, as you take a look at this here, the hydrogen, of course, cannot be the central atom. We know that this is an oxyacid because it gives hydrogen and there's oxygen in it, so we know that those 2 hydrogens are going to bond to 2 of the 3 oxygens. But the central atom that we are going to start with is carbon. We'll put carbon right here with its 4 valence electrons. Now we're going to put 3 oxygens around it. Notice the oxygens will not bond to themselves. They must all bond to the central atom. 1, 2, 3. And I'll put my 6 valence electrons, north, south, east, west. And I'll pair these up here. North, south, east, west. And I'll pair these up right here. And north, south, east, west. And I'll pair these up right here. Now, at this point, oxygen has 2 single electrons, and at least one should be pointing to a singular electron on carbon, which they all do. This is pointing here, this is pointing here, this is pointing here, and technically this is pointing here. Now, we have 2 hydrogens. The hydrogen is going to go on to these oxygens. And it makes no difference which ones they're going to go to. I'm going to put one here, and I'm going to put one here. So that now makes these 2 oxygen central atoms as well as the carbon. Why? Because this oxygen bonded to a carbon and a hydrogen, this oxygen bonded to a carbon and a hydrogen, and this carbon is bonded to 3 oxygens. So by definition, they're all central atoms. So I'm going to identify them as such when we do the linear version of this Lewis-Dot structure. So let's go ahead and start bonding. Now, when we do this, again, we always start with the outermost atoms. Now the outermost atoms at this point are the hydrogens. So we've got to take care of the hydrogens first, because they're on the extreme outside. The oxygens now are kind of stuck in the middle between hydrogen and carbon. So now, that gives this oxygen 2, 4, 6, 7 electrons, and we form a single bond here. That gives this oxygen 2, 4, 6, 7 electrons, each one, so we'll form a single bond here. Now this carbon, at this point, has 2, 4, 5, 6 electrons. Oxygen, 2, 4, 5, 6 electrons, double bond, we're going to share 2 pairs of electrons. So we use 2 circles to show the sharing of those 2 pairs of electrons. Now when the smoke's clear, when the smoke clears rather, we're going to come up with our linear structure. So carbon, oxygen, 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 and actually this is a double bond, that's a cut off, right? That's a double bond, so we'll put another line there. And this is an oxygen here. Now we also have a hydrogen here, and a hydrogen here. Now we're going to put on the electrons. So according to this diagram right here, you have 2 pairs of this oxygen, 2 pairs of this oxygen, and 2 pairs of this oxygen. And again, you can put these wherever you want, as long as they're either north, south, east, or west. In this case, you don't put it on west, either north, south, or east. All right. Now what we're going to do is we're going to identify the central atom. And instead of putting asterisks on this, we're going to identify them below the structure. So we know that carbon is the central atom. So I'll put Ca for central atoms. Carbon. And we got 2 oxygens. So even though they're identical in color bond, we still have to demonstrate this, because if we were to construct a molecule, and we may be doing this if we get lab time in the next week or 2, I think we're going to try and do this. So we have a 1 there for the first one, and a 2 there for the second one. So this is O1 and O2. This is how we're going to identify it, okay? So, this is what it looks like. So, we're going to identify the number of sets of number of sets of electrons around each central atom. Carbon has 3 sets of electrons. Oxygen 1 has 4 sets. And this oxygen number 2 has 4 sets. Now, we go to that chart and identify the degrees that each of those represent. Or you may have done this enough times now where you have a pretty good idea what it is. But if you don't, use the chart, either the hand one that I put up there or the printed out one on the PDF or docs form. For carbon, 3 sets. When we have 3 sets, we know it's going to be 120 degrees. For oxygen 1, we have 4 sets, and we know that when we have 4 sets, it's 109.5 degrees. And for this oxygen right here, again, 1, 2, 3, 4 sets, and that means 109.5 degrees. Now, the next thing we're going to do is we're going to identify the number of bonds around each central atom. In this case here, for the carbon, 1, 2, 3 sets. 3 bonds, not 3 sets, 3 bonds. This has 2 bonds. That's for oxygen 1. We have 2 bonds. And oxygen 2, we have 2 bonds. And now we look at the combination, 3 sets and 3 bonds. In that chart, 3 sets and 3 bonds is triangular. Triangular, or over here, 4 sets and 2 bonds, and they both have 4 sets and 2 bonds. So we're going to write the same answer twice. 4 sets and 2 bonds is bent. So we're going to constructing molecules. Pretty sure we are. Using styrofoam balls and toothpicks to show this structure. So you get a triangular carbon with 3 oxygens in the same plane, and then off at 109.5 degrees, 2 of them will have hydrogens bonded to those oxygens. That's how we do a Lewis dot structure of multiple central atoms.